So hello and welcome to the Staffordshire University webinar on what is intelligent mobility. So my name is Mark Ecclestone. I'm the Innovation and Enterprise Fellow for SCIMIA programme. I've spent over 30 years in mainstream automotive development area, recently focusing on vehicle autonomy, driver attention systems and collision avoidance, particular areas of sensing control. Many of these enabling technologies are applicable now or in the foreseeable future in applications far distant from automotive. I hope this webinar will spark some ideas of where connected mobility can be applied to your product, process or service. So the first point to make, connected mobility is definitely not just limited to robots and self-driving cars. The application impact of technology such as the Internet of Things touches everything in our daily life. So many people ask, what is connected mobility? In my view, it's simply humanity's endeavour to enhance our life with anything from simple tools to autonomous vehicles, enabling us to do more things better, faster and greener. It's always been with us. Arguably, our primate ancestors kicked it all off. And the first innovation of this journey, well, that's up to debate, but the choice is yours. Along the way, we've seen near exponential growth in mankind's potential to automate and connect. And if we look at our world, we can see applications for connected mobility from the ground up. So we have utilities, power and communications underground, industry, transport, commerce, built environments and recreation at street level, and air transport and satellites in the sky above us. All can be affected by and contribute to the connected mobility environment. We can break our world down in several ways. I prefer to look at it in 4 dimensions. The static environment, which is really the geology and topology, which are mountains, dunes and valleys. The built environment, buildings, roads, bridges and our infrastructure. And the installed static environment, which is furnishings, decorations and the such like. Then we have the dynamic environment, which is really mass transportation, personal transportation, process automation and manufacturing equipment, domestic appliances and office equipment. We then have the living world. So the people, the animals, the plants and the environment, water, lakes, seas, oceans. And finally, the soft applications. So the commerce and finance, health and well-being, infotainment, all that sort of software-driven commercialized environment. But really, humanity is very selfish. So everything is human-centric. So all of these targets revolve around us. Okay, moving on more specifically. In terms of technology to implement connected mobility, we can break this down into 5 elements, I believe. First of all, sensing. We start here where we're detecting, measuring, observing. For example, this could be the level of water in a river, the speed of a vehicle, the temperature of an oven. That sensing data is then passed over to an intelligent device, and the intelligence is used to compare the data and decide if action needs to be taken or something needs to be transmitted. For example, in the oven, is the temperature too high? Do we have to reduce it? Is the fluid level too high? Do we open the valve or close the valve? Is the vehicle traveling too fast? Do we need to apply a speed governor or put the brakes on? And at the very basic level, this technology can simply be a switch or very simple electronics. At the higher end, deep learning is applied to handle mass data, current and historic, for such things as weather forecasting. So the next area we go to is the control. So this is where we act on the intelligence we've gathered and the decisions we have made and take the action to change the situation. So this converts the intelligence into a decision in action. Example, opening the valve, reduce the speed. And then we have to communicate this. So this brings us into the next quadrant, where communication is key. Radio frequency, optical, or directly connected systems transfer commands and status between all locations modules within a system. Without the communication element, intelligent connected mobility wouldn't happen. It would be more difficult and less applicable to our current world. And of course, the fifth quadrant, if one such exists, is the power supply and generation. Without power, none of this would happen. So moving on to some specifics. In smart cities, we have challenges. So transportation, congestion, increasing journey density, parking, electric vehicle charging, logistics and shopping, increasing online market, vertical living, high-rise flats, recreation and greening, management of green space, power distribution, increasing demands on infrastructure, accessibility, an environment where the emissions and electromagnetic noise applied by all of our equipment that we're installing causes problems, and also refuse and litter collection. So it's all can have the connected mobility applied as a topic. One example, or sorry, many examples can't really be visualized by manufacturing organizations that are delivering products at the moment. For example, the manufacture of street furniture, such as waste bins, benches, and bus shelters, can contribute directly to the smart city revolution. So waste bins can have technology applied to them that monitor the refuse level, request emptying autonomously, scan recyclable material barcodes and allow for deposit refunds, and contain compaction technology to bundle recycled waste for onward processing. Bus shelters can provide power generators to charge bikes via solar panels on the roof, and also can carry information displays to allow the passengers to understand when the next bus is arriving. And cycle stores can provide secure location, but also charging points for e-bikes. So many applications with very traditional products that can be adapted to move into the connected mobility world. So the smart highway, to enable technologies for smart roads, the enabling technologies, for smart roads have been around for decades. However, as technology has developed, the potential to improve safety and congestion has increased significantly. For example, lighting. Smart lighting now utilizes less than 10% of the power required than was 10 years ago. The spare electrical infrastructure capacity could go some way to enable installation of street level electric vehicle charging points, and the lampposts themselves have become installation points for 5G cellular hubs, traffic and people monitoring sensors. In-road sensors detect vehicle movement, road condition, temperature and wetness, and parking bay occupancy and toll collection. And even the roads themselves can in future potentially become charging points for electric vehicles with inductive charging, and there are some programs on the way that are looking at using the actual road surface itself to generate electricity. And that's just a sample of some of the applications going on at the moment. For interaction with all road users, lampposts and freestanding displays supported by active lane and hazard direction and junction road markings enable the information to be passed directly in a visual manner to the drivers and the pedestrian users. Transmission of traffic condition of roads to vehicle is important for current vehicles, but essential for future autonomous vehicles. So vehicle-to-vehicle infrastructure communication enables the vehicle to become an integral part of the built and natural environment. The level of data interchange has grown considerably over the past years. So there is now potential for active guidance of a vehicle through a problem area, where the vehicle potentially can take control and guide the driver through. A vehicle can be monitored for potential breakdown, emergency situations, and correct supportive dispatch without the need for driver intervention. And with the recent problems with smart motorways, this could go a long way to actually making smart motorways actually a lot safer. Customized infotainment and other content can be shared directly with the vehicle. Currently, that's available. And an important development and extension to smart parking assist in vehicles will be the application of a last 500-meter autonomy, allowing vehicle to park itself without the driver being present, which improves parking density because you don't need to open the doors. Potential to utilize off-road charging again with increased density. Starting with premium vehicle manufacturers in the late 90s, vehicle-to-vehicle communication initially assisted with smarter navigation, avoiding congestion reported from one vehicle to the other in a chain. This has developed into an enabler for significant strides in vehicle autonomy, including collision avoidance, where vehicle front broadcast braking and steering data to the vehicle behind. And finally, driver condition and attention monitoring. AI and face recognition based on artificial intelligence and deep learning are now proving invaluable in detecting the mood, health, and attentiveness of drivers. These systems are already in production now and will be developed further into the future. Into the home, I think this is probably the easiest topic to discuss because everybody's seen the gadgets that are available. There is a multitude of technology available for us to integrate into our homes and offices. And there'll be some major jumps in technology over the next years, enable even smarter, greener homes. And finally, from my last slide, one industry that can benefit greatly from smart mobility is agriculture. From smart farming hubs, where the security, vehicles, plant monitoring, utility monitoring, pollution monitoring, building security is there, to monitoring out in the field, cattle condition, livestock management. All of these are areas that possibly get missed, but are a huge application for the Internet of Things and potential growth for the future. I'll now hand over to my colleague, Nick Wilcox. Thank you very much for your attention.
Thank you very much, Mark. If we could have the next slide up, please. There we go. So I'm Nick Wilcox. I'm another Innovation and Enterprise Fellow at the university. My background is essentially working in smart cities, software development, and the design of sensors and solutions. We'll hop forward one more slide, please, Mark. Thank you. When we think of intelligent mobility, our minds are automatically drawn to things that move. But in fact, that doesn't have to be the case. With the environment also being of concern, projects that can avoid unnecessary journeys are actually of great interest. This could potentially be any kind of journey being avoided or reduced. For example, if we have better methods of communication so that face-to-face meetings aren't required, journeys to a meeting place can be avoided altogether. The automation of the setup of equipment can avoid the need for an engineer visit. And when we think how many engineers are out in vans every day all over the world, then the savings in damage to our environment, also savings in fuel and so on, can be huge. Predicting service calls to enable better planning of journeys can create a great deal of efficiency. And another example, automatic collection of healthcare data can avoid the need for somebody to go to a clinic. So next slide, please. Intelligent mobility is dependent on an ecosystem of technologies to make it work. Mark has already shown this slide before, but what we're going to do in the next few slides is take a look at some of these areas. If your project touches on any of these areas, then it may well qualify support under SCIMIA. Let's consider sensors. I'm not sure that's the right slide actually, Mark. I should have the sensors one coming up next. If we consider sensors, in broad terms, intelligent mobility is about collecting data, processing it and interpreting it, then taking some action based on that data. The sensor is the device that we use to collect the data. Sometimes this could be a relatively simple item. Maybe it's just collecting the current temperature. Other sensors can be very much more complex. For example, in the world of autopilots for vehicles, the sensor could be capturing video or LiDAR data in real time and processing it very, very rapidly to provide decisions on the next control instruction. If you're working on any type of sensor, then we can help you. We have expertise and facilities to bring your sensors into life. I'm going to talk about power next, which hopefully is on the next slide, because power can be quite an important issue in the development of sensors. For example, at Christmas, I was fitted with a heart sensor, and this is an implant. It's fitted underneath my skin, and so there's no way for the onboard battery to be recharged. The device collects my heartbeat data, and then when I'm in range of a base station, it transmits the data to the hospital. Usually that happens overnight. The success of the sensor is completely dependent upon the battery life. Fortunately, this one has a battery life of about 3 years. It'd be extremely inconvenient if I had to have it taken out and have the battery replaced every couple of weeks. It's also fairly reassuring that the NHS thinks that I'll last longer than the heart monitor battery. Of course, many sensors can tap into a ready-made power supply. In a vehicle, for example, there's already a rechargeable battery providing ample energy. And in some instances, we can use mains electricity. But where neither are available, there are two main challenges, and those are capacity and recharge. Again, these are areas where we can help with expertise and facility. So we have our sensor, we've managed to power it. The next step in the chain is to get the data from our sensor so that we can do something with it. Again, the environment is quite important to dictate what technologies we can use. Physical wiring, network cabling could be an option, but if the sensor is by the roadside or in the middle of a field, some kind of wireless communication will be needed. Not only will the technology be a consideration, but also the cost of transmitting our data. It probably wouldn't be worth fitting a temperature sensor with the SIM card, for example, so that we could send the data over a mobile network. But if the application is important enough, then maybe it would. There are lots of options for the transmission of the data, and the location will also help to determine the most appropriate way. Many fixed sensors use different types of wireless communications to a hub, for example, Wi-Fi or Zigbee, Bluetooth, and then they'll use a wired or mobile connection, such as 4G or 5G, to send the aggregated data onwards. Where wide geographic locations need to be covered, technologies such as LoRaWAN may be used. And for global coverage, for example, if we're tracking or monitoring containers at sea, then satellite coverage may be needed. We can help with the selection and testing of the right communications methods for your project. Mark, I think we want to skip forward a few slides because you haven't been keeping pace. If we can go to the one around the data. Next one, that one's fine, thank you. So now we've managed to get our data back to base, we can start to do something with it. Maybe we simply need to collect and store it, ready, for example, for a billing event in the future. Maybe we want to examine the data and look for trends. In a social care setting, we might be monitoring heart rate and blood pressure and looking for declining conditions so that an intervention can be triggered. In a smart buildings context, we might be looking for a trend of increasing damp, one where it's gradually going up, rather than, for example, a one-off event where somebody is boiling a kettle. Sometimes we might simply be trying to predict the future, for example, looking at pollution or traffic volumes, or indeed the effect that one has on another. Building out the software to analyze the data and identify trends, and then present that data in some kind of dashboard is an area where we regularly help. Next slide, please, Mark. The final link in the chain is to trigger an action. If we can predict something's going to break down, we can schedule a preemptive repair. This means that downtime can be scheduled and a costly breakdown avoided. If we know which items need attention, we can better plan service visits, whether this is to empty a waste bin or to restock a vending machine. In the past, I've used shape recognition to monitor footfall and identify when toilets need cleaning. Reducing journeys helps to reduce our carbon footprint and is better for the environment. In another project, we looked at how salt and grit could better be targeted when it was spread on the roads during the winter, with the aim of reducing both costs and pollution. One side effect of many of these projects is an improvement in customer experience. Avoided breakdowns, targeted healthcare interventions, better control of conditions during the delivery of goods all help to make people happier. In the end, there's an economic benefit from happier customers and more efficient operations. Thank you. I'm now going to hand over to Professor Suleiman, who's going to continue.
Hello, everybody. My name is AbdulHamid Suleiman. I am a professor of signal processing and telecommunication in the Department of Engineering. Can we move to next slide, please? I will start with the former mayor of Dover quote about the smart cities. He said in 19th century, the focus was in empires. Then in 20th, it was in nation states. And in 21st century, we are talking now about cities. Focus now about cities and about how to make city more smart. Next slide, please. When we talk about the smart city and the smart systems in general, all of the time we imagine photos or objects like in the left-hand side here, nice car, very smooth design, maybe flying cars and vehicles as well, buildings with very strange shapes. But in reality, smart city, it will be normal like any traditional city, like the one in the right-hand side. It will be a normal city, and in reality all of our cities now, they are smart with certain percentage. I can say, for example, London is a smart city with percentage of 60%, 40% or something like that. Then our aim to go almost to 100% smart city now. Next slide. If we are talking about mobility, you will find many definitions. The most common definition is the first one, optimizing movement of people and goods. But really, I want to make it more broader. We can say movement of people, goods, and the data. Data also is very important part, and this is what we call it telecommunications. Without telecommunications, you will not be able to implement a smart city. Next slide, so I will go through building a smart system step by step, then we will go to practical examples and the case studies. Then if I want to have a smart system or implement a smart system, we need to implement a system can give me smart decision. The challenge here, the word smart is a little bit vague. What you consider it smart, maybe I will not consider it as a smart system or a smart decision. But to have a smart decision, we need first step to acquire the required information about the applications that I am working in. For this reason, I will start with the first block, acquiring data. I will acquire physical quantities like pressure, temperature, maybe cameras as well, because we have two categories of sensors, what we call them traditional sensors like the pressure sensor and temperature sensor and so on. And also for us, camera is a sensor. It is acquiring image, and the image at the end, it is a signal to be processed. The next step after acquiring the data, I will need to process it, and here it will be another challenge to find the suitable processing unit to process this data. It is linked to the nature of the data and linked to the nature of the application. Then after processing the data, I will take a decision, and I need someone to apply this decision. And as my colleagues said, we need to use actuators here. For example, I am detecting the temperature of the room. I will acquire the data. I will, in processing unit, I will see it is in the threshold or not. If not, I need to switch on the air conditioner. To switch on the air conditioner, I need to use something like a relay to switch on the air conditioner. These are the three main items of or components of smart systems. And also, as my colleagues mentioned, there are other hidden elements, like, for example, telecommunications. Telecommunication, it links all of these items together. Can we have more click? Okay. Then telecommunication, it will have the responsibility of transferring data from unit to unit, and at the same time, it is the link between all of the system and the external world. And could be as written here, wired or wireless, also based on the application and based on the nature of the environment around me. Then sometimes the main challenge not in these items, it is in the power source. And sometimes I will see projects on some examples. We'll see, for example, manhole cover monitoring. The main challenge in this project, it was the power, because sometimes there is no source of power close to me. Then power really is one of the important elements. Last element, and this is the maestro of the system, the software. Software really responsible about managing and determining the function of each part of the system. Smart systems could be, we can build it for different applications. Next slide, please. Then the smart systems are not dedicated for certain application. Really, I can build a smart system for energy management, for security, for safety, health, or mobility and the transportation. Next slide, please. Now we will see some practical examples. These practical examples vary between traditional final year projects, master projects, or PhD. Next slide, please. Or maybe consultancy work or externally funded project. Next slide. First project is it is current project, and it is funded by Royal Academy of Engineering, and it is about automating the harvesting process for olives. We have big challenge here because olives size is small, not like apple or like some fruits, orange or something like that. They are big, they are very small. It is they are included with many parts of the tree, like leaves, branches, and with each other. Traditional way of harvesting olives really damage the olives. As you can see in the olives, you find parts of the trees and a lot of leaves on them after harvesting. In our system, we proposed, and we are working in proposing an automated system to make the harvesting process more efficient, and at the same time to try to maintain the tree itself. Next slide, please. Then if we are going through our traditional system, our traditional blocks, we have the tree itself, and to acquire data about olives in the tree, I will use here camera. Then camera, it will be my sensor in this case. Then data is acquired, I need to send it to processing unit, and in processing unit, I will run the software, and my software, we are using a YOLO 5. It is one of the deep learning techniques. It is artificial intelligence techniques, then it is AI technique. In AI, we have machine learning, and the deep learning is a third layer. We are working with YOLO 5 in this project to classify and recognize olives in the tree. As you can see in the image, we recognized olives, and despite that, really it was very challenging because olives, they have different size and different colors as well. And as we said, sometimes or most of the times they are included by other parts of the tree. After analyzing the amount of olives in this part of the tree, and if it is suitable to harvest them or not, then I will give the decision to the robot. I will send the decision to the robot. Robot will start the process of harvesting. We are working now in this phase in the project to use a robot fitted with GPS. Then robot can move autonomously. This system, as you see, acquiring data, processing it, taking action, we can apply it in different applications. Next slide, please. Then I can apply it to monitor road, not tree, but maybe I will use different type of sensors, different type of processing machine, different type of actuators, health monitoring, compass monitoring, or smart compass, fleet monitoring, and so on. At the end, we need to acquire data to be able to give the right decision. Next slide, please. Then now we started to collaborate with one of the Saudi universities. They already implemented this system, and now we want to build a bigger platform to go through it. In Kawast University, it is in Jeddah, Saudi University, they started research in the area to monitor the tree health. Also, part of our project is to work trying to work in tree disease detection. Then in this project, they are monitoring tree health by using drones. Then they scan the whole field and they try to determine the crown of the tree. And then with other robot goes directly to the area they feel there is problem in it, and they can detect the tree health. As you see in the right hand side image here, in the image on the right hand side, condition one, this is a healthy tree. Then step by step we have 10 levels of to determine the tree health. Last one, almost a tree without any leaves, almost dead tree. We are now proposing to work together to build a bigger platform for harvesting, for monitoring tree health, and we are saying we starting from the seed, from putting the seed until harvesting. We are working toward this aim now. Next slide, please. This is other project. It was also in collaboration with external company about road safety and the infrastructure monitoring. Here we were talking about manhole cover monitoring. Really, we did not think about that manhole cover is very important like that. We spend millions of pounds every year just to check and to monitor the manhole cover health. And manhole cover, if is not in the right position, it costs us a lot of money due to accidents and so on. For this reason, we propose the system for early detection for any problem in the manhole cover. Next slide, please. It was a PhD project. Then our proposal, it was to build a node, or to have a node, to install a node in each manhole cover. And this node, I will connect some sensors in this node to detect if the manhole cover corroded or not. If there are some cracks started in the manhole cover, I will not wait until I lose the manhole cover. No, in early stage, I will try to detect and acquire this information. If the manhole cover tilted, if in some places may be stolen, the manhole cover is stolen, and then I will send the acquired data to server and someone will monitor all manhole covers. Unfortunately, because manhole covers mainly metal parts and it is very hard to send signal through them for longer distances, then we will send them to the closest light post or the closest access point, and then it will go to the main server through wireless sensor network. We proposed this solution and the company was happy with that solution, but for the student who is doing a PhD, there is no contribution to knowledge. Then we need to add something new to the system. Then we started to think about the power required for this node. It was very challenging because some places we could not find any close source for power. Then in this case, we started to see what is the challenges in power requirement. Next slide, please. Then we found that we can increase the life of this node by, for example, designing new hardware. Then this node, I will redesign this node to use less power. And this one of the students did it and already graduated now. And there is another researcher working in the processing algorithm, how to work with algorithm to keep the life as long as we can, the node life as long as we can. other part to increase power life, it was not my personal interest, but maybe other colleagues' interest to make research in enhancing battery life and in energy harvesting. Energy harvesting, we investigated, we found that wind or sun or light energy harvesting, it will not be solar, for example, it will not be suitable for this application, and the piezoelectric technology is the best one based on vibration, but unfortunately it does not generate enough energy for this node. Next slide, please. Case study number 3, it was a master project with one also of students about home security, and in this case we used the LabVIEW, one of the products of National Instruments, and we used also hardware from National Instrument, and we implemented a system for for home security and home monitoring, and it can be expanded for building monitoring. What we see now is the prototype in the lab, but he applied this to his home. Next slide, please. He applied this to his home and started to use, wanted to, or proposed to use several types of sensors. Then some of them, if to cover, if there is any malfunction in any of these sensors, the other one will sort it out. Like the one in the left, the magnetic sensor. This magnetic sensor is used for doors and windows. If someone opened the door or window, it will generate a signal, then I can initiate the alarm. But if the glass is broken and someone went through the window without opening the window, no one will detect it. Then he used the other sensor called the glass break sensor, and this sensor, it is tuned for the frequency of the glass breaking. Then if someone trying to break the glass, it will generate signal as well, and I can detect the person. Also, these beds on the right hand side, pressure sensor for entrance and exit points. These beds, he put them in different places, and if these are mechanical sensors, and the optical sensors in the left also can be used. If you are successful, or the thief successful to go through all of these sensors and not to be detected, he has at the end the PIR sensor or motion detection sensors installed in different places inside the home. Then once you go inside, also it will generate a signal and will raise the alarm. Next slide, please. This project, it was mainly, it was from long time. It was case study for Lichfield Cathedral, and it is applicable for museums as well. And really, they had a challenge to build a group for the tours and so on. And for this reason, we proposed a system based on using a mobile phone. Now the proposal is mobile phone. At this time, it was based on BDA. It is something like mobile phone exactly, but without SIM card. Then you will use this system. You will go inside the cathedral or museum. If you see any paint, you can scan the RFID tag beside the paint or beside the statue. It will you can read all information about the statue, who made this statue, all information, all details about it. If you want more details about it, for example, about the person made this statue, I can see some of his works in museum in Italy, museum in USA. Then through the Wi-Fi network, I can contact the server, and I can contact other museums to collect more information. If I am not interested in reading the text, we were using software to read the text, and the majority of people in the cathedral, mainly we were targeting elderly people. They don't prefer, and even not elderly, young people, they don't like to read. Then it is better to have headset and then just hear this information. Next slide, please. This also other system for bladder monitoring, bladder activity monitoring, and in this the aim really it was to use this system for early detection for any disease. Patient will insert this data through the system through mobile device, and this system is already used now. It was in collaboration with a company called MBDTI, and it is used now. This system, it is practically used, and you can see this small device like BDA. It is not BTA, but because the device is used by elderly people, the company did not prefer to use mobile phones. They want a dedicated device with few number of icons, 6 icons or 5 icons, just for the person to click on it and insert the required data. They don't like to go for complex system. And once the patient insert data inside in this mobile device, information will go to computer, it will go to the server. If automatically server will detect any spikes or any change in abnormal change in the patient's records, and then it will send this message to his GP. GP will go to review and revise all the acquired information, and they can invite the patient for more tests. This project we got about we have received about 4 awards for these projects from different levels in national level. Next slide, please. This it is mainly PhD research as well about eye tracking, and in this project we are using we use the two cameras to be installed in the dashboard, one to monitor the driver, to monitor driver fatigue, and the project started like that. But we said maybe the driver is okay, but he does not look to the road. Then we started to monitor the driver if he is looking to the road and if he can see any hazard in the road or not. For example, if there is kid running in the pavement or trying to cross the road, automatically I have two camera will detect the object, the hazard, and the camera will detect the eye and will match the object and the eye, and if will try to detect if the driver can see the hazard or not. If the driver could not see the hazard, it will alert him or her. As you see, these lines in the window screen, they are virtual lines. They are not physical lines. It is just a virtual line to talk about them today. The main challenge here, we are not working in a studio. In a studio, I can track the eye, I can see the eye, I have fixed environment. But in car, sometimes the sun coming from right-hand side, sun is coming from the left-hand side. There is no sun at all. So it was very, very challenging environment for us. Because for us, it is easy. As a human being, we can detect the face with different level of lighting. But for computer, it is very challenging environment. Next slide, please. Then just to about mobility and about data mobility, and I believe data mobility without telecommunication really will not be able to implement any system. This study has been done. You can find it in internet by Cisco. It is a nice study. They asked people from 14 years old till 29 years old, and asked them, I cannot imagine life without. Then 97% said without mobile phone. And mainly mobile phone, when we talk about mobile phone, about communication and about data and information mobility. One click, please. Second item, it was internet, and the internet and the mobile really they are linked to each other. For example, now if you are going to switch on your computer and you could not find the internet service, I am sure you will switch it off and you will leave it. Then 84% said internet. One click, please. Then car or vehicle. Car, 64%. They said we cannot imagine life without car. Then, as you see, first three items mainly about mobility, data or physical mobility. Last one, unfortunately, fourth one. One click, please. It was, I will not say, you can read it, my current partner, about 43%. Then communication and the mobility now, I think maybe some people consider it more important than partner. And thank you very much.
Well, thank you, Professor Suleiman. That was really good, and really interested into hearing all those examples as well. Such a wide range of examples there, and I'm sure the audience can take something from that relevant to their sector. Thanks to Mark and Nick as well for their overview. I think that was really comprehensive. I just want to open it up for questions now for the audience. If anyone has got any questions, please put them in the chat box and we'll get to them. Whilst you're doing that, I just want to give you a very quick overview of the things that we do at the university for businesses. So could you go to the next slide, please, Mark? So like I say, whilst you're putting your questions in the chat box, I'll just run through some of the support that we have. We're lucky that university has got lots of support for local businesses. It covers various areas. The area that we covered today in quite a lot of detail was intelligent mobility, and that is a really growing sector. I read a report by Deloitte that said that sector was worth £900 billion by 2025, and we really want to encourage Staffordshire-based employers to have a small slice of that, which still could be quite substantial. And we've got lots of expertise here in the university about intelligent mobility. You've heard from 3 of our experts. We've got many more, and we're more than open to listen to your own ideas of what products and services you want to develop in that sector that meet some of the remit that we've got there that we went through in quite a lot of detail today. So if you have got any ideas about intelligent mobility, please come to us and I'll put my information up at the end where you can contact us and we'll chat with you about it and the funding. But essentially the funding would give you 6 months worth of support on a full-time basis, and what you would either have Nick or Mark as your innovation consultant, and then you would have a student or graduate, and they would work with you for 6 months, and they would develop that actual program free of charge. And also they would have access to an academic expert like Professor Suleiman and many more that we have at the university. And that would be an excellent team there to develop that for you. And that's all free of charge. It wouldn't cost you absolutely anything. And it's just one of our projects that we have at the university. So that's intelligent mobility. We do the same for digital development. So if your idea is a digital development project, we have funding for that as well, which we can allocate to you. Very similar model where you get a 6-month project with a student, and you also get the academic support to actually do that digital development. So for any of those things, please get in touch with us. As a university, we also have an innovation and startup hatchery, and that's based in our Stoke-on-Trent campus. You'll see one of the photographs there has got one of the facilities there on the photo. Very modern place to work. You get an address, which is a university address, but you've also got access to meeting rooms, etc., and lots of networking opportunities. So if you are a small business, you're looking for a new office, we've got shared offices and we've got private offices available at the university. The other photo there is a piece of equipment that we've got. We've got lots of equipment that's available for companies to actually hire out. I won't go through everything that we've got, but as an example, we've got 8 different types of 3D printers, and those are available to companies to hire out or to use via one of our projects. So we can help companies with manufacturing and prototyping. So if you are a company and you're thinking about prototyping new products, we've got a project there that can do that for you. We've got lots of equipment on site that our students can use. Very quickly going through the rest of this now, we do have funding for apprenticeships. We're actually one of the leading universities for apprenticeships in the UK, and we're very much an early advocate of apprenticeships here, and we offer a huge range of apprenticeships to your staff. So if you do want to have a chat about apprenticeships, we've got a dedicated team here at the university, and they'd be more than happy to sort of have a chat with you about that. We've also got lots of funding for CPD, and CPD is free training for your staff members. Short course, just about a subject that they want to brush up on. We've got about 12 different courses available. And again, please get in contact with us if you want some free training for your staff. We will run through that option in a bit more detail. Of course, we're a university and we have lots of talented students and graduates. If you want to hire a student or graduate from us on a part-time or full-time basis, then please contact us. We've got an agency here that can help you out, and actually they've won an award last year for Agency of the Year for UniTemps, and that was a nationwide thing. So very highly sought after service that's actually low cost, and they offer a very good service. So if you are interested in to recruit students, then please get in touch. Our UniTemps team would help you out with that. And finally, we do support large employers as well. So not just SMEs, we do work with some very big companies. So if you are a big company on the line and you do want some support and you're interested in any of the things that we've mentioned, then we'll have an individual chat with you, as we will with any SMEs. So if you're an SME, you want an individual chat, then by all means, we'll have a chat with you and book a call. Next slide, Mark. I'll just leave up our contact details on the last slide for you. It's got our email address, it's got our website, and just a quick plug that we do plenty of webinars now. We do a couple every month at least about different subjects. So if you did enjoy this today and you want to come to a different webinar about different subjects, please look at our events page, and we have a listed there of all the other webinars, and feel free to book on any others. Okay, so if I can just invite the other panel members back on the screen, I'll just go through some of the questions in case I need to direct the questions at any one of you. So to kick it off, I've got a question here. Do I need to recruit the student after the 6 or 12-month placement? I think I can take that one. The answer to that is no, you don't need to recruit the student after the 6 or 12 months. What you can actually do is just give them a reference, and they will be paid for the time that they're with you in the company. So the student won't have the expectation that it is a full-time job afterwards. Of course, on the flip side, if you have got a vacancy and the student's done really well, then by all means you can recruit them. But just to make it clear, you don't have to recruit the student. It is a temporary assignment, and hopefully that experience and the reference will help them out to get a job afterwards. Another question here. Do the university own any of my IP, and can we sign an NDA? That is actually a really good question, and we get asked that quite a lot. The answer is yes, we can sign an NDA with you that covers you, and the IP is actually all owned by you, the business. So no matter what support we give you, the IP is always owned by you. And the whole idea of the funding is to help your business to grow and to innovate, and hopefully you might want to work with the university again on other things. Another question coming in. Are there any follow-on support options after the Skimia project? Yes, the answer to that one is yes. There's lots of support at university. Some of the things I've run through very quickly: training, CPD, but also we can bid for Innovate UK funding with you as a partner to do something called a KTP. And that could be a 2-year partnership with the university that we could be your partner with to develop that idea even further. So we're very interested in that as well. Finally, if we've got any more questions, feel free to just post them in there. I don't think I can see any more now. So that just leaves me to say thanks again to the panel, and please get in contact with us for more information. And our details are just on the screen there.